Australia is the sunniest continent on Earth.
If we took a square in the centre of Australia of around about 50 kilometres by 50 kilometres, it's 2,500 square kilometres altogether, that would give us enough solar radiation to power all of Australia's present electricity needs.
To date, the cost of solar power components and the difficulties of transportation have inhibited many commercial solar operations. But that's changing. This trial project at Liddell Power Station was an important step in demonstrating the commercial viability of concentrating solar power.
What we do here is generate steam through solar energy and then transfer that steam into the power station. And that transfer of steam means that we can use the heat from that steam in the cycle in the existing power station and offsetting the amount of fuel we burn to generate our electricity.
Now, concentrating solar power has evolved, and in Spain, the Andasol power station combines a parabolic trough technology with energy storage to provide the power needs of a city the size of Newcastle, even after dark. The PS10 plant, also in Spain, uses mirrors and a central receiver tower to generate large-scale power. With several solar technologies having proven their commercial viability, the question now is which technologies will be the most successful. Another Australian technology is a major contender.
This technology concentrates sunlight and generates temperatures anywhere from 400 degrees centigrade to over 2000 degrees centigrade. And so not only are you able to create a quality of steam to match state-of-the-art steam turbines, any commercial steam turbine in the world, but it opens up a whole world of thermochemistry as well.
In Whyalla, the ANU has built Australia's first big dish power plant. 100 homes can be powered from a single dish on a sunny day. By creating modules of several dishes at a time and using storage technology, the big dish is a great option for sourcing large-scale, reliable solar power.
I think this technology is absolutely world-beating technology. It's arguably the most efficient solar concentrator technology around the world.
While solar technology has become mature enough to be rolled out on a large scale, Australian innovation is still finding new ways of capitalising on this renewable resource. At the CSIRO, major efforts are underway to make the sun's energy more accessible, storable and exportable. 500 kilowatts of energy is now being generated from these 200 mirrors, enough to power 150 homes.
All of our components here are off the shelf, our actuators are off the shelf, and so by using these cheap mass-produced components, we can actually build a much cheaper field than might be built in some of the other solar thermal installations around the world.
Solar gas can also be converted into liquid fuels like methanol. This liquid solar fuel is then transportable, and transportable means exportable.
We can bottle up our sunshine, we can put it on a tanker, and we can ship it to those countries that need our sunshine.
The technology is here. Australian government policy now needs to rise to the potential of large-scale solar power, funding major projects and providing long-term security for the industry.
I've worked in the power industry in the past for many years, and so I know the realities of the power industry, the realities of needing to provide reliable power to people, but you know, an area like this really excites me because I can see that it really can start to make a big impact on the way we use and generate our electricity in the future.